Okay, in this presentation we're going to look at reliability analysis, survival functions, and so on. Suppose the lifetime of a machine follows a distribution with a cumulative distribution function of f of x, capital of f of x, equals 1 plus e to the minus x over 6 minus 2 times e to the minus x divided by 12, okay, for x greater than 0. Calculate the mean and the variance of the lifetime, okay. Now, so I'm going to be sort of quick about this one. So essentially what we're going to do here is integrate the survival function. And the survival function is simply the complement of the cumulative distribution function. So s of x equals 1 minus f of x. Okay, so you could just pick that out there and just change the signs. Okay, that's as simple as that. Okay, I've reordered it as well. So what we have to do here is calculate the first two moments. Now, so these are some key expressions here. Okay, the moments of a random variable, in this case the distribution. So in this case it is the this is the general expression here. Okay, now there's a derivation for that I won't get into, but the first moment, t to the power of 1 is the expected value of t to the power of 1. Okay, and the second moment will be used to calculate the variance. Okay, so here k is equal to 1, and in the second instance k is equal to 2. Okay, and they both stem from this formula here, so this is one you sort of really got to know if you're using this type of approach to solving these questions. There's a derivation for that as well. I won't get into it in this video. Okay, it's probably the type of thing that you'll actually be asked to derive from first principles, so it's well worth an entire video. Anyway, so just as a quick remark, what you have to do, you notice we're dealing with exponentials. Okay, so essentially just be ready with all of the possible combinations of how to integrate a term with an exponential in it. Okay, so you should have these off by heart. Okay, so e to the x dx, when you integrate that you get ex plus k. Just that's the coefficient of integration there, so you can just disregard the k's there. The key thing here is the coefficients there. Okay, now you're going to see this one a lot. Okay, an expression in terms of that, or actually if you can rearrange your expression so that it fits that sort of shape, it makes life really easy. Okay, probably, you probably won't be given tables or anything like that if you're doing survival analysis, but just sort of like almost write it out as a little formula up at the top of your exam page. Just write out that little formula there. This is what I'm using. Just makes it very clear what you're doing and speeds things up, and then the examiner knows what you're doing and you can just move on. Okay, so anyway, I digress, but essentially you really need to all have these off by heart, because this is first year university type stuff and you should be well past that. Okay, so if you're not familiar with these, go back and study these. Okay, so anyway, the expected value of x is the expression here is the integral from 0 to infinity of 2 times e to the minus x over 12 minus e to the minus x over 6. Okay, now you see what I'm going to do here. I'm going to split up. I'm going to sort of set this up in terms of this last expression here. So I have 1 over c as the exponential here. Well, minus x over c. Okay, that's the power of the exponential. So what I'm going to do is reorganize the coefficients such that they fit that form. Okay, so go back down here. I have minus x over 12, so I want 1 over 12 here to precede it. Okay, So I have 2. So 2 stays where it is. Okay. And I have e to the minus x over 12, and that's over here. Okay. So I'm going to just sort of insert this 1 here. So 12 times 1 over 12 is 1. So we could just stick that in there, no problem. Okay. So what I have there is I multiply this out, 2 times 12. Okay. And I get 24 here. Collect that up, and I get 24. Okay. And now I have this expression here. 1 over 12, the integral of 0 to infinity of 1 over 12 times e to the minus x over 12 dx. Okay, I'm doing the same thing over here with this one. 6 times 1 over 6 times the exponential of minus x over 6 dx. Essentially what I've done there is just split it up into 2 different integrals. Okay, so just to sort of make it a little bit easier to follow. So I have minus 6 times the integral from 0 to infinity of 1 over 6 times e to the minus x over 6 dx. Okay, so I'm using that this expression here. I'm using it here, and I'm using it here. So 1 over 12, the exponential of the integral of 1 over 12 times e to the minus x over 12 dx. That is minus e to the minus x over 12 evaluated from 0 to infinity. Okay, that works out to be 0 minus 1. Okay, and that ends up as just 1. Just remember, we were preceding that. The constant of that before we multiply that integral out is 24. Okay, and likewise minus 6. When we evaluate that at infinity, we get 0. When we evaluate that at 0, x equals 0, we get 1. So that works out to be 1 minus 1 as well. Okay, plus 1. Okay, 0 minus 1. Okay, so it's minus 6 times 1. Okay, and we get 6. So anyway, the expected value works out to be 18. Okay. So there's a lot going on there. I grant you that. This is the key part here. Okay, once we sort of create our expression like that, or rearrange it, then it's fairly plain sailing. You know, I know it looks a bit dense there, but it works out fairly easy. Just as a remark, when you evaluate those definite integrals from 0 to infinity, anything to the power of minus infinity is considered to be 0, and anything to the power of 0 is 1. Okay, just in case that you haven't spotted that yet, e to the minus infinity is taken to be 0, and e to the power of 0 is 1. Okay, that's a mathematical convention when you're dealing with infinity. Before I continue on, I'm going to clarify a calculation. I have the integral here, that is the integral of from 0 to infinity of x times 1 over a times e to the minus x divided by a dx. What I'm going to do is factor out the 1 over a there, and I'm going to use integration by parts to solve that part there. Okay, so I'm going to let x equal to u, and therefore du is equal to dx. I'm going to let dv equal to e to the minus x divided by a dx, and therefore we can calculate v by integrating that, which is the integral of e to the minus x a dx. Okay, so you should get that expression there. That's why I sort of keep saying you have to be very good with these integrals of exponentials with various types of expressions in the power. Okay, now we'll just continue this on a little bit further. We're going to integrate that with respect to du. Okay, and that is dx as well. So essentially we're going to integrate it again. So essentially we're going to do the same thing again. It is we're going to go minus a again. So minus a times minus a gives us a squared. times e to the minus x over a. Okay, so uv minus the integral of v du. There we have it there. Just remember from earlier on, we have to divide by 1 divided by a. Okay, so piecing everything together, we get e minus e to the x minus x divided by a times x plus a plus the coefficient of integration there, k. Okay, now this is interesting. What happens when we... This is a very interesting expression here. Okay, essentially the integral of x divided by a times e to the minus x divided by a dx from integrated from 0 to infinity is simply a. So that's very handy. Okay, now I'm going to go back up here. I sort of skipped past this part here. This is the second moment. Okay, 2x times s of x dx, get the integral of that. So we have 4x times e to the minus x divided by 12 minus 2x times e to the minus x divided by 6 dx. Okay, so I'm going to do something similar to what I've done before. Okay, I am going to split out this part here. Okay, so I'm going to split out x into 12 times x divided by 12, okay? And I'm going to bring this 48 outside. Likewise, 2 and 6, going to bring it outside, okay? So I have these two internal expressions here, x divided by 12 times the exponential of minus x over 12 dx, and likewise x times x divided by 1 over 6 times x multiplied by 1 over 6, which is x divided by 6. The exponential of times the exponential of x, the exponential to the power of minus x over 6 dx. You get very tongue-tied with these things. So that simply works out to be, in this case, a is 12, and in this case, a is equal to 6. Now, so it looks very complicated, but you just pick out the number. 12 and 6. So we have 48 times 12 minus 12 times 6, and that gives us 504. So that's the expected value of x squared. Okay, now just remember, you're not finished until you've done this part. The variance of x is the expected value of x squared minus the expected value of x to be squared, the mean squared. 504 minus 18 squared. Calculator work is 160. Sorry, 180. Okay, good. Now that's good. We'll leave it there. There's a lot in that. Just the key thing there really is you have to be super fast with these things. Okay, these sort of calculations with integrals and exponentials. Okay.